Hi, this is Lori, and welcome to my series on the Pico W. We're now ready to start including buttons or switches in our projects. When we use buttons, we'll also have to learn about something called pull down or pull up resistors. And this two-part series, we're going to create a game called Capture the Light. And in this game, we'll have LEDs and a button, and we'll want to react quickly to pressing of the button. With that, we're also going to need to learn about a concept called interrupts on our Pico. So this is part one, where we'll cover buttons and pull down resistors and interrupts. And in part two, we'll do the full game and get it running. It's always good to start with the end in mind. So let's do a demo of the Capture the Light game. You can see I have everything set up here on the breadboard. Here's our Pico, and we have this row of LEDs and our button. And we'll go over how to hook up the button later in this episode. The way this is going to work is it's going to start and it's going to light up the LEDs in succession, and it's going to kind of pass the light back and forth among these LEDs. And our goal will be to capture the light by pressing the button and stopping it on the green LED. That'll be a perfect result. And then if we stop it on one of the yellows, that'll be okay or good. But if we hit one of the blue LEDs, well, that's a miss in the game. Let's see it go. All right, so it's going back and forth. And I'm going to try to capture the light. And I got a yellow. And you can see in the shell that I got a good, and it tells us it's going to restart in 5 seconds, and it's already restarted. Also tells us how to end the game. Let's try one more time. Maybe I'm feeling lucky. I got an excellent. Awesome. Now let's leave the game. We'll do a Control-C, and we get thanked for playing. So that's the game we're going to have by the end of part two. Let's talk about buttons. They're also called momentary switches or tactile switches. And a switch is a component that controls the flow of current in the circuit. So it can either be closed and the current can flow, or it's open and the current cannot flow. Here's a diagram of a circuit with a switch and an LED. And if we activate it, you can see as the switch closes, current flows, and the LED lights. Here's some pictures of the typical buttons that we get in an electronics kit. And they're kind of funny looking, and I have to always remember myself exactly how they're connected up. So they usually have these little legs on them that are kind of pointing, and the ones that point toward each other are connected to each other inside the button switch. So B and C are connected to each other, and A and D are connected to each other, as is shown in this part of the diagram. And when we press on the button, it closes up the circuit, and the current can flow through the button. And you can kind of see, here's a picture where somebody took one of these switches apart, and you can see the metal plate that when you press, it engages both sides of the button and connects all the legs. This is the first circuit we're going to create to learn how to set up buttons. We're going to use a button to turn an LED on and off by pressing the button. Press it once, it'll go on. Press it again, it'll go off, and it'll make it toggle back and forth for each press that we do. It's a simple circuit. Here's our Pico, and here's our LED with its current limiting resistor coming back to a GPIO pin. And then here's our button. And you can see these green lines here show you the two sides of the button that are connected. And one side of the button will connect to the power rail, and the other side of the button will connect back to a GPIO pin on the Pico. The next thing we'll need to learn about is pull down and pull up resistors. And we use those with buttons to keep the voltage on our pins of our Pico from sort of floating around randomly when they don't have any input coming into them. So a pull down or a pull up resistor will ensure that the pin is always in a low or high state when there's not an input. I have a diagram here of the pull down and pull up resistor. With the pull down resistor, it's connected to ground, so it will pull the pin to a 0 when there's no input. And here's our switch, and the switch will be connected to the positive rail or 3.3 volts. And the pull up resistor is kind of the opposite of that. The switch is connected to ground, then connected to the pin, and the resistor is then connected to the power rail. You can actually create a pull down or pull up resistor by putting a resistor on your circuit. But our Pico provides to us the opportunity to use an internal pull down or pull up resistor, and we just tell the Pico in the code that we want one of those as we set up our button. So I have the circuit for both the pull down and pull up resistor here. We'll focus first on the pull down. And you can see this is the code that we'll put in our program to set up our button and to tell the Pico that we want a pull down resistor, for example. So here's our button connected to 3.3 volts, and then it's connected to the GPIO pin. And then inside the Pico, so this is kind of a little bit of imaginary diagram here, but inside the Pico, it's going to put in place a resistor for us and connect that to ground. And that's the situation that we have here. That is the pull down resistor. The resistor is connected to ground inside the Pico. Here's our pin, and then here's our switch, and the switch is connected back to power. The pull up is the opposite, as we've seen in the diagram before, but now we're going to connect our switch to ground and then back to the Pico, and inside the Pico it's going to connect to a resistor and then connect that to 3.3 volts and giving us this situation over here. And then you can see here in the code for the pull-up, we'll tell the Pico that we want the pull-up resistor in this situation. I was curious to see the impact of the pull-down resistor and see if I could observe this floating voltage that's on the pins when we don't have those resistors in place. So set up an experiment here with our circuit, and I've connected my multimeter up to the ground rail, and I've connected the positive side of the multimeter up to the pin that we have our button connected to. So I'm going to turn it on, and we should be able to observe the voltage now. And we can see that it's bouncing around a little bit here. And I've written a little program to import the needed libraries and set up the button. And you notice I'm not including the pull down resistor in this setup. And then in the while true loop, we're going to print the value of the button, and we'll kind of loop through that every 0.2 of a second. Let's kick that off and see what happens. We can see the 0 because the button is not pressed. It's registering a 0. And we can see the voltage is continuing to fluctuate. So that must be the floating voltage on the pin. I'm going to go ahead and press the button. Let's see what happens to our voltage. Now it goes up to 3.3, which is the voltage we'd expect from our Pico. And you notice that's not floating. That's input to the pin, and it's not floating around. If I let go, it goes back to that sort of floating state. All right, let's finish the experiment by setting up the button with our pull down resistor. So we're going to go ahead and stop this program. And let's run the one where we put the pull down resistor in place. All right, and you might have noticed right away, once we started the program, that the voltage went down to nearly 0 now. So it's pulling it down to 0. We don't have that fluctuating state anymore. And let's see, if we press the button, we go back up to 3.3 volts. That's the role of the pull down resistor. Now let's get our circuit set up to turn on and off the LED with our button. We'll import the needed modules. We'll set up the button with the pull-down resistor. We'll set up our LED as an output. And in our while true loop, if the button value is equal to a 1, then we're going to toggle the LED. We're going to sleep a little bit to do what's called debouncing the button. So when you press a button, it sometimes has some flickers of voltage. And if you don't have enough sleep time in here, you can register more than one button press from a single press. So we'll need to sleep some amount of time to make sure we don't have that happen. Let's see if this one works. All right. Press the button. Looks like it works pretty well. Now in our game, we'll want to have things happen pretty rapidly, so we may not want to sleep this long inside our while true loop. Let's see if we could take some of that time out. So I'm going to take a fair amount out and see what happens if we do that. Let's run that one. You can see that's we're registering more than one press for each press. So we don't have enough sleep time in there to debounce this circuit. So that's not a way we can speed up the game program by just taking out some of the sleep time. So that's going to make us want to go to another approach, which is called an interrupt. So what we were previously doing would be called polling, where we read the button within our main program in one of the steps of the code, and then we do all the other things we need to do inside the code. And we need to run it fast enough so that we can catch when the button has been pressed, but obviously not too fast that we run into debouncing problems. So that kind of an approach is called polling the button to see when the value has changed. We can see that it doesn't always work when we want to go very fast like we will want to for our game. So the other approach we can use is called an interrupt. And there in the main program, when we press the button, it doesn't matter what line of code we're on. It immediately registers the interrupt, goes to the interrupt function, runs what code is there, and then comes right back to where it was in the main program. So that is the way we can handle having button presses register very quickly without having to have a lot of sleep time to debounce the button. Now we're to our last program for part 1. We're going to add the interrupt to our button LED circuit and program. So we'll start off pretty much similar to before. Import the same modules, set up our button and LED. We're going to add 2 variables, an interrupt flag, which says when was the interrupt activated. If it's 1, it has been activated. If it's 0, it hasn't. So that means the button has been pressed. And then a debounce time. So inside our interrupt function, we're going to check for those fluctuations to make sure that we don't register multiple presses for the same single button press. Here is our interrupt function. So it's a Python function. We'll define it, and we'll have the button pin be our input. We'll make global the interrupt flag and debounce time so that those 2 variables can be seen in the main program and inside the interrupt function. And this if statement checks to make sure that we're not registering a button press that's just fluctuation. So we have to have a greater amount of time, greater than 300 milliseconds, before we're going to say that's a real new button press and not just a fluctuation. If that happens, we'll turn on the interrupt flag and we'll reset the debounce time to the current time. Then we'll come in and we'll use our interrupt request. And that's kind of activating the interrupt function to run. So we'll associate it with our button, and IRQ is our interrupt request. The trigger is that the pin for the button is rising to a 1, and how we'll handle that is using the button handler function. Then we're going to get into our while true loop, which is pretty simple. It just says if the interrupt flag is equal to 1, in other words, the button has been pressed, we're going to immediately turn it back off so that the next button press will get registered. We'll print that to the screen, just say we detected an interrupt, and we'll toggle the LED. Let's see this one run. All right, and let's press. And we see interrupt detected. Went to the shell, press again, press, press, press. It's working perfectly. It doesn't have double presses, and it's turning on and off every time we press. But we don't have any sleep in our while true loop at all to debounce the button, so this interrupt is a cool concept that will really allow us to go a little further with our game. So I hope you enjoyed this first setup episode where we learned several good skills, and we're now ready to tackle our Capture the Light game. See you next time.